Okay, what we're going to do, and at times we'll do this with labs, we're going to walk through and work some of the problems that were involved in the lab, all right, just to make sure that we are on the right page. So this is our post-lab for the accuracy of glassware. Now, when I come down and click on, here was the very first thing that we did at the start of the lab, okay? The very first thing that we did is we labeled, all right, what do we think? What do we think? So, I don't see it on here, but Maya, what did you think what did your group think as the most accurate to the least accurate? What do you think? Don't remember? Okay. Well, hey, I can look here. I'll just take this top one. They said that the most accurate was the volumetric flask, so we'll put a 1 there. Second was the Erlenmeyer. Third was the graduated cylinder, and beaker was the least accurate. So that person, that's how they rated those. So we'll keep that in mind. Volumetric, Erlenmeyer, graduated cylinder, then the beaker. Once again, we're just going to show you the beaker and the markings there. The volumetric flask only has the 1 marking. There's the graduated cylinder, and there's the Erlenmeyer. Now, I heard different groups at times during the day having different conversations about this, and I even said, I think it was in this class, if you don't disagree, you and your partner don't have to have the same answers. You can answer it differently if you don't agree. So that was the order, and here we go. We had an actual volume of water that we needed to calculate. So as I'm looking at the data here, I see that my temperature was 23.0 degrees Celsius. So with that value, 23, that means that right here is the density that I'm going to be using for my calculation. And we see, I have even included it, we had a little bit of problem with that, so make sure somewhere you have your volume, mass, and density equations for density. So my volume is going to equal my mass divided by my density. Well, I know my density for that temperature is 997,541. So that was my density. As I look at the data here, I can see that the average mass of the volumetric, the average mass was 24.14 grams. That's grams per milliliter. So when I do my math here, I have 24.14 divided by 0.997541. So I come up with a volume, and I'm going to have 4 sig figs here. 24.20 milliliters. I go on to the graduated cylinder. Volume is equal to 25.54 grams divided by my same density at that temperature. So when I do my math there, I have 25.54 divided by 0.997541. With 4 sig figs here, I get a 25 0.60. Moving along down, the beaker, my average mass with the beaker is going to be 23.81 grams. I put my density at the temperature again, and I come up with a value of 23.87 milliliters. And my final one, let me move that guy out of the way. My final one down here for the Erlenmeyer is going to give me a value of 23.41 grams. 997.541 grams per milliliter. So my volume for the Erlenmeyer is going to be 23.47 milliliters. So now I've done my experimentals. I've got all of my experimental data here. I'm going to go on then to my percent air. So I know theoretically that I'm dealing with, I was supposed to have 25 milliliters, correct? Now, based on our theoretical value, we're going to use that as 25.0. So I come back and I look and I say 24.21. 24.21 minus 25.0 divided by 25.0, and I'm going to multiply that by 100. So when I do the top part with the absolute value, I come up with a value of 0.79. Okay, 0.79. I can only have it, since I'm adding and subtracting there, I can only have it to the 10th. So I'm going to keep that 0.79 in my calculator, but I'm going to know that I've got 1 sig fig up there. All right? I'm going to keep the 7.79 because it's going to be more accurate in the long run, but I know that I've got 1 sig fig. So they take that 0.79, divide that by 25, multiply by 100, and I get a value of 3% air for the volumetric flask. Come back 25.60. 25.60 minus 25.0, absolute value it. So I'm going to have 0.6 divided by 25.0, multiply it by 100, and I'm going to have 2.4, which is going to give me 2% air. 23.87. 23.87 minus 25.0, absolute value, 25.0, multiply it by 100. So now for this one, I have a 1.13 up at the top, the absolute value there. So when I take that right here to the 10th spot there, I'm going to have a 1.1. So I'm going to have 2 sig figs on this particular one. And that's going to give me 4.5 And then finally with the Erlenmeyer 23.47, 23.47 minus 25.0 divided by my theoretical. So when I do my math, the top part's going to give me a 1.53, so I'm going to have two sig figs here, a 1.5. So I come up here with 6.1%. So now I get back to my original question. Which one of these were the most accurate? Well, based on our data here, if I've got to rate these, my most accurate one is going to be the one with the least percent air, correct? So based on my data here, we're saying that number 1 is a graduated cylinder, number 2 is a volumetric flask, the beaker is 3rd, and the Erlenmeyer is 4th, based on my order. Okay? Now, I would have to say, based on my knowledge of these instruments here, that that's fairly accurate. I would expect these two to be flopped, because I would think that the volumetric flask would be a little bit more accurate than the graduated cylinder. Now, obviously, the beaker and the Erlenmeyer were the least accurate. So what does that tell you? Well, it tells you, hey, if I have to measure something, if I got to get a volume of a liquid, what am I going to use to measure it? Am I going to use a beaker? No, that's not very accurate. Okay, not very accurate. I'm not going to use an Erlenmeyer. I'm going to use one of the top two, a volumetric or a graduated cylinder. Okay? Any questions for me on that? Awesome.